Today we are welcoming David Anderson. David is the Chief Executive Officer of SAGA Wisdom, and he'll cover this in more detail. But for those of you unfamiliar with SAGA, it is a teaching and content company focused on providing best-in-class educational resources and on-demand services for subsurface petroleum disciplines. So what that means for this group is that with David's focus on technical education, there could not be a more perfect speaker to join us for today's Lunch and Learn, and we're extremely grateful and excited to have him for the next hour or so. David is a University of Calgary grad with over 23 years of oil and gas experience and is known throughout the industry for all of his work in rate transient analysis, including being one of the original architects of Phucket's RTA software. For anyone using IHS Market's Harmony product today, that's, you're using part of David's work there. So it's pretty exciting. David has taught training courses all around the world and has co-authored over 40 technical publications and is an extremely active SPE member, with being both a distinguished lecturer and having served in multiple program and technical committee positions within SPE. I hope everyone had a chance to read through the abstract for today's topic, but today David will be covering a reservoir engineer's guide to fit-for-purpose completions with minimum spend for maximum performance. So a very pertinent topic. And with that, I will turn it over to David. Thank you very much for joining us.
All right, so the subject of my talk is Reservoir Engineer's Guide to Fit-for-Purpose Completions, minimum spend for maximum performance. I got interested in this talk, or the subject matter, mostly because I'm a reservoir engineer by trade, but I spent the last 5 years of my career working for a completions company, running a subsurface advisory group. So I got to see firsthand the disconnect that often exists between what we do as reservoir engineers and what completions and asset managers and asset teams do. So what I did, and I originally put a lot of this content together quite a few years back, and it's very basic stuff. It'll be, I saw some of the names on the participant list. It's going to be a review for a lot of you, especially if you're an experienced reservoir person. But I think it's a good, these are some really good basic concepts to remember. I think as an industry, we don't always practice what we preach. And I'm not going to say that asset teams don't listen to reservoir engineers, but maybe there isn't always a very clear objective when trying to make the best decisions around completions. So I'm going to focus on some of these things, go through some of the what I think are the most important considerations for getting the right size completion fit. This is obviously also a very relevant topic now, given the market conditions that we're in. Companies are obviously looking for opportunities to maximize the bang for their buck. Capital allocation is always important, even in good times, but it becomes critically important whether you've been a good allocator of capital when the market collapses as it has done in the past few months. So let's talk about some of these things. I'm excited about this topic. Hopefully you guys will get something out of it as well. My company, SAGA, this is a fairly brand new startup. We just got going with this in the last couple of years. Super excited about it though. This is, as Peter mentioned, this is on-demand training for the energy industry. What we do at SAGA is, and I've been involved in continuing education my whole career, so I've seen kind of firsthand where some of the frustrations are. And we offer masterclass instructors and content in several different areas around the subsurface disciplines. But what we do, which is really different, is this concept of a guided collaborative training experience. Where some of my frustrations have been in the past is that training is really done as a single sort of transactional type experience, which can be valuable, but it doesn't always hit all of the expectations. You go and take a short course, you engage with that instructor, you get some value out of it, then later on you're sort of trying to remember what you learned when you're trying to apply it in the workplace, and that's always been a frustration. So our platform's a little bit different. It's a subscription-based solution. So the time element is a lot different. You're exposed to experts and have access to a stable of instructors and experts in all of these different disciplines, and access to structured content as well, along with these guided programs that go through a whole period of time with multiple transactions rather than just a single course. And the subscription service allows unlimited access to all of this content, so you're not just buying individual courses. So it really is a revolutionary kind of model. There's nothing else like it. If anybody is on the call is interested in this, feel free to email our info or email me directly, or drop a line. Check out our website and learn a little bit more. Okay, so now on to the talk. So what is a fit for purpose completion? Fit for purpose completion, really, if you want to distill it down to its essence, it's the most profitable allocation of completion capital. At the end of the day, what are we doing if we're not making money, right? I mean, this is what we're doing as oil and gas companies. We're spending money on designing a well, designing some sort of field development program, and hopefully we're allocating that capital properly. Everybody understands this equation: profit equals revenue minus cost. I think as an industry, we understand the cost side of things pretty well, and we've done an exceptional job as an industry, especially over the past 5 years or so, of lowering the cost, both capital cost and operating cost, in these unconventional plays. What we don't understand as an industry very well is how those decisions relate to revenue, how it actually drives revenue. And that's where the reservoir engineering perspective and expertise comes in. And I'm going to try and show you how we can link that up with the completion side of things, and hopefully make better decisions with a little bit of effort, but none of this stuff is really what I would call rocket science. It's all pretty basic stuff. And then I think we've got some time. So after I go through some of the fundamental concepts, I'm going to show you some of the trends. And I originally designed this talk for a Canadian audience, so most of my statistics are Canadian statistics, so bear with me on that. But we'll go through and look at some of what I've seen in the production and completion trends over the past 5 years. So fit for purpose completions, really what we're talking about here is, this is not an exhaustive list, but this is a pretty good list of some of the things you should be considering. And really this list would constitute most of where the capital is spent on completions and well design. So things like landing depth, what type of completion technology do you want to use, number of frac stages. So the rest of this stuff really relates to frac intensity. How much money do you want to spend on your treatment? What type of treatment do you want to do? I think most of you on the call probably know and have been witnessed this firsthand, but the combined cost of completions, when I started my career, it was a drop in the bucket. It was probably less than 25% in conventional applications. Now that we're getting into shale and these ultra-tight reservoirs, the combined cost of completions routinely exceeds 50% of the total capital cost of well construction. Again, Canadian statistic, but this number is probably almost certainly larger in plays in the US. But in the Montney in 2016, this was more than $1.5 billion spent just on making these decisions. So obviously this is going to be an important thing. If we're spending this money, we want to make sure we're spending it in the right place. So I like to draw these little diagrams. These are not meant to show specific quantities of anything. This is just more of sort of a conceptual schematic that shows where you should be focusing your efforts. Okay, so this is a very sort of simple thing. If we look at it, we have completion intensity on the y-axis and increasing permeability going across the x-axis. Okay, so where do you want to put your efforts on completion intensity? Well, most people would agree that you're going to do that in the lowest permeability reservoirs. So these are your ultra tight rocks, your shales, your siltstones. And then in the more conventional rocks or even conventional tight rocks, you don't need as much completion intensity. So let's say that you've correctly identified the design that sort of fits and you've got the right completion intensity. This is a common operator mistake that I see all the time. And again, over the past 5 years, we've worked as an advisory team looking at these completions, and we've seen this firsthand. And this is what I'm going to call inflexible design. And I'm sure you've all seen this and witnessed this as well. You have a design maybe that you've used and it works, And even within the same play, you move to some different acreage, some adjacent acreage, and you find yourself either undercapitalized if that's tighter rock, or overcapitalized if that's not as tight rock. And believe me, this can happen within the same acreage. For example, the Montney in Canada spans, ultra tight all the way up to almost conventional tight. And if you don't adjust your completion design to account for the fact that you're doing different geology, even within a neighboring, section, you might have something totally different. You have to make those adjustments to account for the reservoir. Now, most reservoir engineers know this. This is just, this is reservoir engineering 101. But a lot of times, the decisions, at the asset management level don't properly take that into consideration. Okay, another common operator mistake that we see is misallocation of completion capital. So here we have operators routinely spending money bolstering links that are not weak. And I like kind of the concept of using a chain here, right? So what is it that's in your value chain in your reservoir, that's reservoir completion surface system, that's the weakest? And in all assets, this is going to be different. It may be the reservoir itself in terms of low permeability. This is what we normally see in these ultra tight plays. But it may be something different. If it's higher permeability system, that may not be the weak link. So some examples of this is designing a high conductivity frac in ultra low permeability plays. I've seen tons of this happening. So this is an overcapitalization issue. Or using high frac stage density and micro-millidarcy permeability. I'll show you some examples of this later on. The trick is really to figure out what that weak link is. Don't spend money on stuff that's already strong, that it's not really going to affect your bottom line to improve it, other than you're spending money where you don't need to. You want to make sure you're spending money on the, in those areas where it's really going to add value for you. All right. So another common operator mistake that I see is, this is probably the most important one in terms of connection to the markets and investors, optimizing the wrong metric. Okay, so throughout, I would say, 2005 to about 2015, this was a common story. Optimizing, for example, 30-day IP or completion cost. These are kind of two end members, right? Two opposite focuses. Companies that were sort of hell-bent on growing their production would really emphasize this 30-day IP. And we saw tons of this in Canada. I know there's lots of this stateside as well. But that's not necessarily the most profitable solution. The plot I'm showing you here is an NPV graph, which is probably your best measure of profitability. And if you were minimizing your completion cost, you're not actually getting the best NPV. So that's an example of probably being too conservative. As you can see, it's the lowest completion cost, which would be indicated over here, but you're not necessarily getting the best NPV out of that. And then maximizing your 30-day IP actually gives you a horrendous NPV in this case. Although it's going to look really, really good to potential investors in the market because, hey, look at this, I got this great well, this boomer. But that doesn't necessarily relate to cash flow and profit down the road. You're not getting your capital back when you do it that way. So profitability should be a primary consideration. It's not always going to look the best coming out of the gate, but it's going to give you the best, the best profitability, which means you're allocating that capital the best, which means best long-term longevity for your company. So how can we ensure that completions are fit for purpose and capital is allocated profitably? Well, maybe it's just because I'm a reservoir engineer and maybe I'm not objective about this, but I think the first thing you have to do is understand the reservoir. You can't go designing completions when you don't understand how the reservoir is delivering that, that product to you, and what are all the drive mechanisms, what are going to be the influencers of well performance. So what are the primary drivers of well performance? We need to relate the input variables to the output performance. That's notoriously difficult to do. You're talking about a multivariate sort of situation, right? You have all of these inputs that you have to make decisions on, and a very tenuous connection between that and what you observe on the output side of it, which is well performance. How can we tie those things together? That's, if it was easy, everybody would do it. And I don't have the silver bullet. I'm going to tell you that right now. But what I do have is I think a pretty practical way to direct you, away from the noise and look at what are the important things. Where should we really focus our attention? You cannot solve the problem of allocating capital, and in other words, designing completions without understanding economics. This is a big one in my mind, and most reservoir engineers are pretty good with economics. So allowing the reservoir engineer to have a seat at that table, I think, is a valuable thing. They're innate, that's part of most of their DNA, is to understand what's profitable and what's going to work and what's not going to work in terms of the economics. So we run these reservoir models and we layer in the economics and try and run sensitivities on top of that. So we want to optimize. Okay, why should you care? I really designed this slide. I've given this talk to investment bankers and private equity people and all kinds of investment folks that don't understand reservoir engineering. So bear with me on this one, but it's a good review. Even for technical people, I think it's a good review, because what it does is it shows you, as a reservoir person or a completion person, a technical person working in this industry, how your decisions are being viewed and really where it's leading to the bottom line. So effective allocation of completion capital is just one factor of many deciding what's a good company and what's a bad company. There's numerous companies who have no concept of fit for purpose but have stellar market performance. I think that might have been true in 2015 and 16. It's probably not so much true anymore. Most of those companies, because think about it this way: if you are not good at allocating the capital that you have, and you have a market collapse and investment money dries up, well, you're not going to be around for too much longer. Okay, so the fit for purpose concept, I think, is very much weeding out companies that simply spend, debt or equity money to increase production without really looking at cash flow and profitability as an indicator, or as a tenet or guidance of how to do things properly. Other companies that live by fit for purpose but have mediocre market performance. Okay, so it's not obvious when you look at companies in the market from an investment perspective which ones are doing this right. But in the long run, it's going to all come out in the wash, believe me. It's a multi-billion-dollar spend, as you guys know. Sooner or later, its influence is going to be felt. I'm going to say that that's really happening in a big way this year. The market and most evaluators, I'm going to say in general, don't really have an understanding of how completion decisions relate to well performance. Even very, very experienced evaluators sometimes don't have a good understanding of this. So it's not an easy problem to solve. There's a lot of trial and error. There's a lot of work that needs to be done. Okay, so what I want to do, because this could be an enormous scope, I want to sort of distill it down to what I think are the top 5 most important completion decisions. And my caveat here is that this is really designed around unconventional plays. If you're in a more conventional regime, these wouldn't be the top 5. In fact, you'd really be looking at different things. But I'm focusing my efforts here on pretty much what we do on onshore North America, which is these, shale plays, unconventional type, horizontal wells, multi-fracked horizontal completions. So that's really what I'm going to be tailoring this to. And not surprisingly, this is all going to focus around treatment and frac treatment and completion for the most part. So frac surface area, treatment size, frac conductivity, frac complexity, sort of the top 3 that go with the fracture, right? The area, and I'm going to define all these things so you guys, most of you understand this already, but we'll make sure we get a solid foundation of what these things mean. So we have our area and more importantly, how they're different from each other. So we got our frac area, we got our conductivity, we've got our complexity. And then completion compartmentalization, that's really comes down to your stage spacing. And this one's a little bit different, but arguably can be the most important in some scenarios, and that's your well placement. And I'll show you some examples of that, how that can be important in a way that you may not even realize from the outset. And each reservoir requires a different formula for these things when you're considering them. So let's start with frac area. The equation that's sitting there is just Darcy's law. And so if we're looking at primary production drivers, you always have to have a source of energy. You have a mobility of the fluid, and you have flow area exposed to formation. So there's your production, there's your energy, which is usually a pressure gradient, and there's the mobility of the fluid. And of course, what's left there is your flow area. Now, the mobility of the fluid and the flow area are both contributors to well performance. If you already have good mobility, flow area isn't as important. Okay, but if you have poor mobility, which you do in these unconventional plays because the permeability is so low, then flow area becomes critically important to the process. So you can see it right there in the equation. That's why it's going to be so important to maximize fracture area in order to get good well performance. Let me show this in a simulation, and it will kind of make sense with some real numbers. So this is a horizontal gas well. We have 800-foot drainage area, 100-stage completion. And I'm going to show a comparison of two cases. One, ultra low permeability, like in the double-digit nanodarcies, and then one with, you could call it high perm from an unconventional perspective at 10,000 nanodarcies. And we're going to do two different, look at, end members of 50 feet and 250 feet. These are the frac half lengths. Okay, so you have 50-foot frac half length, and then you have 250-foot frac half length. And so there's a number of simulations here that show the influence of that frac length or fracture half length on your 5-year gas recovery, which is just one of many objective functions you could look at. But 5-year cumulative production could be a pretty important one for most asset managers, I think. And so what you see here is that your higher perm shows almost no influence, which I think is surprising to a lot of people when they realize this. Over 5 years of production, 50 feet or 250 feet, if you're looking at 10,000 nanodarcies. Well, 10,000 nanodarcies would be considered tight rock. Okay, your 10,000 nanodarcies, I think, what's that going to be? 10 microdarcies, which is basically 0.01 millidarcies. So there's areas of the Bakken, there's some areas in the Powder River Basin, mid-continent, there's some oil areas that are of this permeability. And so it's not that frac area doesn't matter at all. You probably have to have a minimum amount of frac area, but it certainly doesn't matter as much. Now, our 10 nanodarcy case, it is almost completely proportional to that EUR, that 5-year EUR. There's a linear relationship. In other words, for every square foot of frac length you can add, you're proportionately increasing your accessible recovery of resource. So if you can add more frac area for a cheap cost, you're going to want to do that because you're going to improve your net present value on that every time you're able to do that. So very different drivers in those two cases. So I want to distinguish that very importantly from frac conductivity. Okay, frac area is what we just talked about. Frac conductivity, very different story. Frac conductivity, the way we define it as reservoir engineers and also frac designers, completion designers use the same definition, luckily, which is good, is this dimensionless fracture conductivity. So what matters is not the actual value of the conductivity in the frac, but what matters is the dimensionless conductivity. And so we have, let's define this. So we have fracture conductivity is equal to the fracture width multiplied by the permeability. And then we have reservoir conductivity or reservoir transmissibility, which is reservoir permeability multiplied by the fracture half length. So this is a relationship between what's going through the fracture and what's coming into the fracture. So let's say we had a frac design where we were trying to get a 15 millidarcy foot frac conductivity, and we want a 150 foot frac half length. What I'm going to show you is that this design could be good for one reservoir and really, really bad for another reservoir. Let's look at the Eagleford. So the Eagleford is ultra low permeability. We're talking about like double-digit nanodarcies. This is an overcapitalized design in the Eagleford, and the reason is because your CFD is 1,000. And I could show you. I don't have the slides here, but I could show you the difference between a production response with 1,000 FCD of 1,000 and FCD of 100. That's a 10 times difference in frac conductivity. Would have almost no difference in production. Certainly no difference in, say, 5-year recovery or even 3-year recovery. So this is an overcapitalized completion. However, if you did this completion in the Cardium, which parts of the Cardium, which is a tight oil play in Alberta, Canada, has somewhat high permeability. So this would be considered not really unconventional, but just tight, light oil. Now you have a dimensionless fracture conductivity that's 1. In other words, your fracture is completely ineffective. This number needs to be usually, at least 10. Very often it's designed between 10 and 20 to get it sort of right-sized. Although there are some subtleties there. Getting CFD right-sized also depends on the reservoir. For different reservoirs, that number needs to be different. So the design of a fracture conductivity is not one size fits all as well. You need to take into consideration the reservoir rock or the reservoir permeability. This is my favorite one, complexity. So we talked about frac area. We talked about frac conductivity. The third one is frac complexity. This is probably one of the most misunderstood concepts in the industry. It's one of those things that sort of everybody's got an opinion about. And the impact of frac complexity from a reservoir engineer's perspective is entirely different from the impact of frac complexity, for example, from a geophysics or from a completion perspective. They may not be complete, they may be at absolute odds going different directions. So I'm going to talk about it from my perspective as a reservoir engineer, and you can take from that as you will. What we have here are 4 different possibilities. We have, and this is where it becomes important to distinguish between gas reservoirs and oil reservoirs. So we have ultra-tight gas reservoir, ultra-tight oil reservoir, and we have a reservoir with frac complexity and a reservoir with no frac complexity. So 4 different possibilities. Now, I know this isn't an audience participation talk, but if you had to guess which one of these, there's 3 out of these 4 will produce a commercially viable reservoir. The 4th one will not. You could probably get it. It's a fairly easy question. These 3, the gas reservoir can give you a good, a viable reservoir, even if you have no complexity. Complexity. I'm having problems saying that word today. Complexity. The ultra-tight oil reservoir, if it has no fracture complexity, will not give you a commercially viable reservoir. And we've seen this. We can see this in some of the failed attempts to drill in some of these plays. If there is no fracture complexity in nanodarcy rock, you're simply not going to get any oil flow. So that's the reason why I bring that up is to me, that's from a reservoir engineering perspective, that's the most important aspect of complexity, is whether you're dealing with a gas reservoir or an oil reservoir. You don't necessarily need it. Frac complexity is a multiplicity of area, so it's going to provide value in any reservoir rock, but you don't necessarily need it for gas reservoirs. Okay, so it creates a multiplicity of total frac area. Obviously, it's going to be good. That's going to be beneficial to well performance in any reservoir, but it's a dominant performance driver in those ultra-tight rock saturated reservoirs, oil saturated reservoirs, and it's less important in gas saturated reservoirs. The other thing that maybe is a controversial opinion, but it's my opinion as a reservoir engineer, some of the frac specialists don't agree with me on this, but I think that frac complexity, your ability to influence it with a treatment is minimal. And really it's controlled primarily by the geology, right? It's there or it's not there. You can use, slick water and diverters and 100 mesh and things like that to help improve complexity if there is already a propensity for it in the formation. But if there isn't, you're not going to create it where it doesn't exist. So really your only option is increased stage density. So we can overcome the lack of complexity by creating more stages and using a brute force approach, just simply creating more frac area. And so let's talk about that. That's completion compartmentalization is one of the breakthroughs in drilling and completion technology that's allowed the shale revolution to occur in the United States. So without completion compartmentalization, we wouldn't be able to, well, we wouldn't be, I was gonna say we wouldn't be where we are right now, on many different fronts, right? We wouldn't have been able to make the US a net exporter and have this energy independence and have this, enormous growth in production that's occurred over the past 10 years. So this is huge. We did a paper back in 2015. I worked with the folks at Devon Energy. And the idea here was to look at some optimization of completion design in the Powder River Basin, which is what I would call more of a light, tight oil. So it's not ultra tight, but probably in the microdarcy range. And what you see with compartmentalization is it's very much a function of economics. In other words, you can support much greater stage density if you have a higher oil price. I think we all kind of understand that. You can still make these completions profitable at lower oil prices, but you need to spend less on your completion because you're going to be, you have to, it's a question of NPV like always. So it's a multivariable optimization. This isn't a back of the napkin calculation. You need to look at lots of different variables: oil price, completion cost, well spacing, frac design, expected well performance. These things all have to come together in this design. And there's a lot of companies doing this and doing this very well now. So this is one of the things where, in my opinion, that's been a benefit in the industry over the past, say, 5 to 10 years, is this multidisciplinary approach to solving these optimization problems. You can't do it alone as a reservoir engineer. You need to combine the completion aspects, the geoscience aspects all together to solve these problems. All right, so let's look at an example. Again, this is from the Montney in 2015. At that time, they had a $2,300 per ton frac treatment design. I'll bet that those costs have come down significantly since then. Although the oil price at that time was $40, and it's about $40 right now as well. So what you're looking at here again are these NPV plots, and this is a multivariable optimization. So it's an optimization both of the stage spacing and the fracture treatment intensity on the same graph. And what we see here is that there's a bunch of different things going on. I think we can all pick out what the best solution is based on these different treatment options over the time scale provided. But let's say you were only interested in the first 5 years. Well, then you'd actually get a different answer. So this tells you that your objective function is also very important to define. If your time horizon is only 5 years, and you're not really looking at the overall EUR, that's like a 40 or 50 year EUR, you might actually get a different answer there. So this kind of gives you the full picture, allows you to make the proper kind of decision. Another thing that goes along with compartmentalization is frac placement. And you might say, well, okay, so how do we control frac placement? Well, the short answer is it's very difficult. As a reservoir engineer, in many ways, I'm going to say you can't control frac placement. You can control where your frac initiates, but it's going to end up in the reservoir where it's going to end up. That's controlled largely by in situ stresses and the fabric of the rock. But what I did, and I did this simulation years ago, but I think it still kind of holds up as a good indicator of how important frac placement or how valuable frac placement can be. If you compare, for example, a standard 50% cluster effectiveness, which I think is a pretty standard metric that people would apply. It's been shown both in operator studies where they measure it and in simulation studies, frac simulation studies, that you don't get 100% cluster effectiveness in a plug and perf completion. And so what you get is these parts of, this is a pressure map. You get parts of the reservoir that are left undepleted, and this is ultra low permeability. If you're somehow able to improve that cluster effectiveness to 100%, you get a much better result, to the tune of, granted this is a net present volume at $50 oil, but that would be a $7.5 million difference and we use this concept of net present volume, right? It's a volume that's discounted with some discount factor to account for time value of money. At $40 oil, maybe that's a little bit less, but it's a significant amount. So if you can somehow create, and I think this is going to be important, with spending money on completions in a down market, you need to optimize everywhere you can. So if you can improve that cluster effectiveness, when I worked at NCS, we had a solution for that was cemented liners or cemented sliding sleeves with pinpoint completions. So we use this as a sales pitch a lot of the time. But the problem with those completions sometimes is they're also more expensive. So there's multiple factors that need to be weighed into that equation to get the best result out of this. So that's your frac placement. All right, last but not least, we have well placement. And this is a little bit of a divergence. Everything I've talked about up until now has been in the frac treatment itself, looking at the area, the connectivity, the complexity, the compartmentalization. What I'm talking about now is we take a step back and actually look at the well design and landing on the target depth and where's the geosteering, where am I going to be looking at it, designing my my drilling and my target landing depth. And again, this is a Cardium example that we looked at years ago. And I'm going to say that well placement is a sometimes overlooked or undervalued variable. If I were to ask the audience, where would you land your target depth in one of these horizontal completions? I think most of you would agree, and I would agree as well. Well, I'd put it in the best hydrocarbon porosity, right? I mean, that's obviously where I want to be. I want to be in the place where I have the best access to the reservoir. Well, the subtlety that happens here in this Cardium example is if you land in the best porosity, some of your fracture is going to go up, some of it's going to go down. And what the frac model, this is a commercial sort of frac model that was run that shows that you end up with a pinch point here. And the production simulator will tell you that you're essentially cutting off half of your fracture due to these gravity, these viscous forces not being able to overcome gravity. So that's something that we've seen in multiple cases, not just the Cardium, but other plays as well. It turns out that if you landed your well somewhere below, probably in the lower third or even lower, which to some people would be somewhat of a counterintuitive, but you actually get a better result because your frac is going up and now you're able to mobilize more of those liquids and using gravity, essentially making gravity your friend. So well placement becomes important consideration. If that didn't convince you, hopefully this will convince you. This is the optimization study we did on that Cardium example. The dotted green line that you see here is the base case. This was the completion that the operator was wanting to do, a 40-stage completion with the well landed, right in the middle of that best porosity, 0.5 tons per meter. And what we were tasked with here was looking for, what are all the variances on that completion design? What happens if I ramped it up to 80 stage? What happens if I bring it down to 20 stage? And that's what the two solid black lines are here. And what that tells you in the Cardium anyways, that stage density has almost no impact or very little impact on well performance. So you wouldn't want to spend money, putting all these extra stages in there. That's a bad allocation of capital, right? What about treatment intensity? Well, if I ramped it up to a ton per meter, I can actually get some benefit out of that. And so maybe I'd want to consider that. If I bring it down to 0.5 tons per meter, I'm losing some productivity from that. But by far the most influential thing to do here is to change your landing depth, to land lower in the pay, and that breaks out of the sort of bounded optimization completely, and doubles the EUR profile over those first 5 years. So it makes a huge difference. And the operator in this case ended up going with that solution, landing in a different depth than what they were considering at the beginning. So it's just one of those things, you sometimes you're looking in the wrong place to see where to optimize, and you need to take a step back. And that's what well placement is really all about there. Okay, so just to summarize some of these ideas on fit for purpose completions, I want to start by just looking again at, there's really two sort of roadmaps I want to discuss. One is permeability and one is fluid type. Because these, as a reservoir engineer, these are the biggest considerations in the reservoir that are going to dictate how I look at the completion and how I try to optimize the completion. So if we're looking at permeability, for example, in these ultra tight plays, as I went through with the examples, the importance of frac area and stage spacing come to the forefront. Again, this is just a qualitative plot. It's not meant to give you any numbers or anything like that. It's just like, what should you be focusing your efforts on? Well, in plays like the Duvernay, if anybody knows what that is, that's a Canadian play, but we have the Eagleford, the Barnett, some of these plays. Haynesville is not on here, but that would be another consideration. Parts of the Wolfcamp in the Midland and Delaware Basin, these are ultra tight shales, and you want to maximize frac area and stage spacing. In these more conventional tight plays, it's not that frac area isn't important. It's just that it takes a back seat. It has secondary importance, and we can do optimizations to show this, and it becomes very clear when we run the reservoir models. That reservoir connectivity and well spacing. Why well spacing, you say? Well, well spacing becomes important in these environments more because you're able to see much further into the reservoir past the stimulated rock volume to the actual well spacing boundaries a lot sooner. So your well spacing actually becomes a very important consideration in some of these higher permeability plays. Not that it's not important in the low permeability plays too. One topic I've completely left out of this discussion on purpose, just because we don't have time, is the issue of infill drilling and frac hits and all of this stuff that occupies a lot of the current discussion in the industry. That would be an entirely separate talk, and I've got some materials on that as well, but I'm purposely leaving it out of this talk. Anyways, that's your sort of your roadmap for permeability. Fracture conductivity versus frac area. Okay, so again, this is like treatment design 101. If you're a frac or completion engineer, you already understand this stuff, so it's just a review. But it's good, for the reservoir engineers in the crowd to have this as a review as well. Conductivity is really creating this, this pathway. That's what's important for conductivity. Frac area is about creating as much, this multiplicity of fractures that are all connected together, which is either a result of complexity that's in the rock already, or multiple frac points that are created by doing higher stage density and adding more stages. Okay, what about liquid yield? That's the other roadmap I want to sort of show here. And I mentioned, with frac complexity, there's a big difference between gas and oil. And so this kind of shows the 30,000 foot view of that. If we're looking at dry gas, again, fracture area, frac conductivity become important considerations. If we're looking at high liquid yields and getting into the volatile oils and black oils, well placement and frac complexity become much more important variables to consider. Again, these are just guidelines. So very quickly, I'm going to go through a few completion trends that we've seen. These are a little bit out of date, but they show, I think, what I want to show, which is the enormous amount of growth in the completion side of the business, and just how much effort and resources have been put into this over the past, say, 10 years. These statistics are for 2006 to 2016. So what we see is improvement in drilling efficiency that's more than doubled in feet per day. Average lateral lengths have almost tripled. Stage counts have gone up a factor of 5 to 25. Proppant loads have increased from 200,000 to 7 million. So enormous, almost exponential increases in treatment intensity along every sort of element, from well design itself to the fracture treatment to the completion. So we get to these sort of landmark events, and these were, I think, 2016 when both of these occurred, where companies have built, constructed, ridiculously long lateral, 18,544 feet. That made the news. That was Eclipse Resources, and then Devon did their 54 million pounds of frac sand in one well. I don't know if either of those feats of strength have been repeated in the industry. We probably won't see completions like that in 2020 or maybe even 2021. I don't know. Maybe there's places where these are warranted, but in general, we always need to ask the question, are we over optimizing or over capitalizing? All right, so some completion trends. These are Canadian plays. I'm not so interested in these, but what I really wanted to show you here is that decisions that operators make on how to right size their completion or what completion strategy they're going to use are not always informed by the science and the reservoir engineering as the underpinning. Sometimes they're informed entirely by environmental conditions, such as in Canada, for example, we have completely different structure for service company contracts. We have different metrics for the oil price. There's a big differential between the Western Canadian Select and WTI. There's all of these different factors that come into play. And this becomes extremely clear when you compare, for example, the Bone Spring. This is a frac intensity in tons per meter. This is all from the public database. And it's an average of what operators are doing. And I'm comparing the Bone Spring with the Duvernay. And the Bone Spring is a play that a lot of you probably, I'm sure, are familiar with in the Permian. And we have reasonably high permeability in the Bone Spring. In some cases, around 0.01 millidarcies. In the Duvernay, we have 100 times less permeability. And yet what you see is a completion intensity that exceeds, in 2017, exceeds by 50% what was happening in the Duvernay. If those decisions were being informed by reservoir characteristics, that would not be happening. So I won't make a comment here on who's overcapitalizing and who's undercapitalizing. I think probably the answer, the right size is somewhere in between. I would say maybe Bone Spring is overcapitalizing. For certain, the Duvernay folks are undercapitalizing their completions. But this just tells you, and that's an average. That tells you a lot of operators are not following necessarily what the reservoir tells you they should be doing. They're sort of following the environmental factors. I'm running out of time here. So I want to show these plots because these are great ways to show that connection between that. Remember I showed you right at the beginning, revenue equals profit, or profit equals revenue minus cost. These are plots that can sort of give you some indication, at least empirically, as to whether the additional production you're creating by intensifying completions and adding more to your completion is actually yielding results. So when you start to see these trend downwards, that means diminishing returns, right? So your production is normalized to tons of proppant. And it's not to say it's a bad thing. If the proppant is cheap, that might still be valuable, right? But if you see it flat like this, that means you're definitely not optimized. You're still undercapitalized. So these are things that we look at. This is D&C cost as a function of time. Obviously, this has all come down. If we were extending this to 2020, we'd see these numbers even lower now. And another one is cost normalized production. This is good news, right? We see we're getting more barrels out of the ground at a lower cost. That's what this is telling us. And again, these are Canadian plays, but we'd see the same things happening in the US. The interesting thing is that if you're looking at a liquids rich play, there's a big difference between a BOE that's reported here. If you have, say, CGR, if it's like a gas condensate, for example, and CGR is over 120 barrels, your D&C is paid off in 1 year. If it's a dry gas, and mind you, these numbers are from 4 years ago when gas price was a little bit lower, but I think they still hold true, fairly true today. Only 30% of your D&C is paid off in 1 year. So public data doesn't always give you the full story, right? You need to know the mix, and the product price is obviously different between the liquids and the gas. So this just gives you some strategies. Light, tight oil. Again, it's just a summary of what optimizing those 5 different fundamentals. And so if we're looking at light, tight oil, these are the higher end of the permeability spectrum. Some of the optimum completion strategies that you should be looking at. Landing depth is going to be really important in these plays. Surgical frac placement is going to be important because a lot of these plays are thin, such as the Bakken. I don't know about the Niobrara, but areas in the Powder River Basin have that same, have some of those same characteristics. Sand control is critical. I think I put that pinpoint completion there as a plug for NCS when I worked for them. And some operators, I know this is true in Canada, almost certainly true in the US as well, are significantly overcapitalized in these plays. In the ultra tight plays like the Eagle Ford, the Wolfcamp, we see some very different things going on. These plays tend to be a lot thicker. If they're not, if they're thin, they're probably not profitable, which is why we see thicker plays that have sort of taken the limelight. They're attracting more investment because they're because they need to be that way in order to be profitable. So this is where we see our stacked lateral developments. We want to try and maximize frac height, maximize treatment volume, and many operators over-design for connectivity and under-design. If there's any one thing that I've seen in these areas, it's an over-design for frac connectivity in these liquids-rich plays that are ultra-tight. So some final thoughts. Completions are not one size fits all. Hopefully, if you weren't convinced of that before, you'll come out of this with that as a takeaway. Reservoirs don't care about changes in market conditions and costs, but we do. As reservoir engineers and people working for oil and gas companies, we have to coax the right solution or the right, what we want out of the reservoir. We have to maximize what we get out of that reservoir, and that's what we're doing with the completion. And that is a huge function of market conditions and environmental conditions. What is perceived as value by the market is not always intrinsic value. Hopefully that point came across as well. So with that, I will wrap up my talk and say thank you very much. I'm a little bit over time, but I think we still got some time for questions. Peter, I'm not sure how you want to run the questions here on Zoom. I imagine you have an idea on how you want to do it, so I'll leave it to you.
Yes, sir. Well, thank you very much. That was terrific. Thanks for running us through that entire presentation. For anyone that does have a question for David, if you could just message it in the group message or privately to myself, I'll just read it aloud to the group. I think that's the best way to kind of communicate each of the questions in a constructive way to David. So I don't see any questions yet, but if there are any questions, please shoot them my way. But one question that I have for you, David, is thinking back to the slides where you showed kind of the overcapitalization versus undercapitalization. Are there specific basins that you would say are trending one way or the other? And if so, is there one metric that's really driving that over or undercapitalization?
Yeah, let me just try and get back to there first of all. I think you're talking about this one, right?
Yes, sir.
Yeah. Yeah, you know what, I can only speak from my own experience. I would predict that it's probably happening everywhere to some extent. But where I've seen it firsthand is that we've done a lot of work in the Cardian formation in Canada, and I've definitely seen it there. I've seen completion designs, and honestly, at the time, I couldn't fault the completion team for doing it the way they did because they were, what was gaining returns on investment at that time were headlines of maximum 30-day and 90-day IP. Those were the metrics that were being rewarded in the market. So that was 100% what they were going for. It hurt my soul because I know as a reservoir engineer, I was like, no, guys, don't do this. And they were sort of like, they heard that message and it was like, we understand, but this is what we're doing. And ironically, for the completion company, that's actually good news because they're buying more sleeves, they're buying more proppant, they're ramping up on everything on horsepower. So the service companies actually win in the short term in that situation. I think now, fast forward to now though, you're absolutely not going to see that now in this market environment. The companies that at that time sort of forewent that strategy and said, we're not going to chase that production growth. We're going to be more disciplined and grow our production on cash flow. And there's companies that do that, and they've gotten through this market pinch a lot better, a lot more unscathed. So that was the one example where I really saw it firsthand. But I would imagine it's happening everywhere.
Okay. Perfect. I appreciate that answer. One other question I have for you is, as you were just kind of talking about, there's this big reshift away from IPs to more, a true focus on profitability of wells and free cash flow. With the recent M&A activity going on and kind of the combining of cultures, do you think that will create a different approach in any way towards completion, or is that shift still going to be there, and is that still going to be kind of the new prize to capture?
I gave up a long time ago trying to sort of predict what people are going to do. I've had this idea of fit for purpose like completions for the last, like as long as I've been involved in looking at completions. So at least 6 years. And I think, I mean, I don't know if I'm answering your question, but it's probably like a politician's answer. Companies are going to do what they need to do. And so I think a lot of what happens is more reactionary than anything else. It's like, they're not going to change what they do until they're sort of forced to. It's not to say that some companies aren't proactive. Absolutely, a lot of companies are proactive. But it really depends on kind of what the corporate culture is and how they're sort of used to making decisions. So I mean, I've stood on the soapbox telling people this stuff for a long time, and sometimes it's like it resonates, and sometimes it doesn't. I don't know if I answered your question, but
no, that's we certainly don't have a crystal ball, so that's a great answer to kind of a convoluted question.
I think that the companies that survive this, though, are going to have to, whether they think about it this way or not, that there's no doubt that, your biggest, if the biggest thing you're spending your money on and your biggest cost in your industry is not properly optimized, how are you possibly going to survive, especially in a low price environment, right? So there needs to be ways. And the knee-jerk reaction is always the wrong one, which is like, okay, well, we'll just stop drilling, or we'll cut down, we'll only go with the lowest cost solution. Well, that's not the right answer either. I showed that in one of my slides here as well. It's the minimizing cost is not minimizing your completion cost isn't the right answer either. That's not necessarily going to give you the best NPV. There has to be, and if the play doesn't, if the product price you have and the play you're in doesn't offer an NPV curve that makes you a rate of return that beats your cost of borrowing capital, then you're in trouble. You better find a creative way to get through that, or go look somewhere else. And a lot of companies are sort of coming to that horrible realization right now in some of these plays. I think there's solutions though where people can be creative and find ways around it. Just takes a multidisciplinary approach. You really need to look at the reservoir, the geoscience, the petrophysics, the completion all together as one system.
Perfect. Sounds good. I did have one question get a message to myself. So I think it's in regards to this slide that you actually have pulled up right now. And it's, do you consider the Niobrara within the Powder River Basin to be an ultra tight zone? And where would you put the majority of operators kind of on this graph specifically? So
full disclosure, I'm not my experience in the Niobrara, unfortunately, is very minimal. So you guys can educate me on that. I put it in here. That's sort of my estimate based on talking to a couple of operators. But to be honest with you, I haven't done detailed work. The analysis I do is rate transient analysis, and I've maybe looked at like 1 or 2 wells in the Niobrara, whereas the Montney I've looked at hundreds of wells. Eagleford I've looked at, where's Eagleford on here? Eagleford I've looked at hundreds of wells. Niobrara not so much. So I'm gonna make myself look stupid if I comment too much there.
Fair enough. No, that was a very specific question, so thanks for trying to field it. Maybe the last question I have for you, just based off the time we have, is you during your presentation you spoke about working with some PE backs, and the question is, do you see under or over capitalization more prominent in certain sizes of companies? And do you see a discrepancy between a public or a private or a PE backed company in their approach?
How much time do we have? I think, again, I'm going to dance around your question a little bit. I think the whole paradigm of the PE-backed, investment in the oil and gas industry in general has been one of overcapitalization. It's been one of, because historically there's been a lot of available cheap capital. And market valuations have risen sky high as a result of this paradigm of growing production, exponential growth production, without really paying attention to the underlying profitability. And I think that paradigm is coming to an end. So it's really no difference whether it's a public company or PE-backed private company. I think it's the same. I think a lot of these companies were built the same way, and the ones that so a lot of them now are finding themselves in a position where their investment dollars have dried up, and they're now sort of stuck holding the hot potato, right? They have all of these assets, but they're not structured in a way where they have a system where they can grow their production with their own cash flow. They're not, that's not their fault. I mean, that's the model that they were built was a different model, and now they're trying to adjust to this new reality, right? This new market reality. So how does fit for purpose completions fit into that? Well, I think that's the fundamental thing that would control what it really is it's a growth model. It's a slower growth model. It's certainly not as exciting as what we've seen over the past 10 years, but you're essentially growing, you're running the company with and growing with cash flow that's raised from production and operations, right? So your investments your investments and allocation of capital have to be profitable in order for that to work. So
that's a terrific answer from kind of like a holistic approach. So I definitely appreciate that.
Yeah.
Well, awesome. That brings us to the top of the hour. David, thank you so much for your time and putting this on for us. And everyone, thank you very much for joining. We will be sharing the recording of this with everyone, so you can visit it again if you need to look back at anything or anything like that. And David's contact information is available in the slide deck as well if anyone wants to reach out to him about SAGA or if they have any specific questions about the presentation.
Yeah, thanks a lot, everyone. Appreciate it.
Philip, did I miss anything?
Nope. Sounds great. Thank you very much, Peter and David, and thank you for all of our attendees. Have a great day.